All right, let's do this thing. So in 7.4, this is matrix properties and operations. Okie doke. So the first thing we want to do is talk about the different properties of a matrix. So if you have a matrix, it's going to be in this box, kind of like what we did with our row transformations, right? So I'm going to have this box deal here. And then I have, I don't know, some numbers in there. Because I'm super creative, we'll go with 1, 2, 3, 4, 5, 6. When you identify a matrix, you always identify as row by column. So if I'm looking here, these are my rows. And then I have my columns, right? Same thing as like an Excel spreadsheet or any other table out there. You've got your rows going across your columns. So for this one, then you say how many rows you have by how many columns. So this is a 2 by 3 matrix. Does that make sense? Okay. So, excuse me. Here's example 1. We have this matrix. 6, 5, 3, 4, 5, -1. What are the dimensions of that? 3 by 2. Good. 3 rows, 2 columns. What if I have 3, -5, 0, 2? What's that one? 4 rows and 1 column. So that's a 4 by 1. Does that all make sense? Okay. So when we talk about matrices, we want to work in terms of rows and columns because that's going to help us determine if we're going to put these together. When I have a matrix such as this, here is matrix A. It consists of 2, 1, P, Q, and matrix B is X, Y, -1, 0. So if I want to determine what are those same values, so if these two matrices are equal, if A equals B, then we want to say, okay, well, what are all of the different variables? So you literally just look, if these two things are equal, whatever's in this top left is equivalent to the top left. Do you see that? So in this instance, it is X equals 2. All right, what does Y equal? 1. Exactly. Do you see? So it's just exactly where it is. P equals -1. Good. And Q equals 0. That's legit what it is. So it's just wherever it is in that same spot, then those are equivalent. It's literally that easy. It's nice, right? Cool. Okay. So let's talk about this. In order to add or subtract matrices, they have to be the same dimension. So if it's the same dimension, it's the same kind of concept that happened up here. In order for us to work this out, the 2 and the X are in the same spot. So if I am going to add these together, they have to be able to add all of the same spots together. So if I want to add, I'm going to stick that down here because we should have room for this. If I want to add these matrices, I've got 5, -6, 8, 9, and I'm adding that to -4, 6, 8, -3. So you literally are just looking 5 plus -4, and that's going to give you your new matrix. So that's going to be 1, right? 5 plus -4. Then you, pardon me, you do the same thing. -6 plus 6 is 0. Good. And then you have 8 plus 8, 16. Yep. 9 and -3, is 6. And that is your answer. That's why they have to have the same dimension, because you have to be able to line those up. Cool, right? Pretty nice to start off with our videos and doing a nice easy one here. All right. What if I have something like this? Here's example for A, approximately. -5, 6, 2, 4, minus -3, 2, 5, -8. So the same thing applies to minus as to addition here. So they have to be lined up. Now, I'm subtracting everything in that second matrix. So think about what we did whenever you had parentheses, right? You would have to distribute that. So the same thing's going to apply here. Now, 98% of success in mathematics is organization. We know that now. So I'm going to take this negative and I'm going to distribute it to every single term. So when you distribute that negative to every single element in that matrix, then it changes all those signs. I highly, highly, highly recommend you distributing that negative first, changing those signs. Because just like with a polynomial, if you leave this out, then you have the option to forget one of them being negative. So let's do this thing. If I were going to distribute that, we've got that done. Now you add what's left over. -5 plus 3 is a -2. 6 minus 2 is 4. 2 minus 5 is a -3. And 4 plus 8 gives us that 12. And that's our answer. Adding and subtracting is no big deal. The biggest thing that is a thing, if you will, is that they have to have the same dimension. If you don't have the same dimension, then you're out. For instance, I don't know if you guys can hear that or not. But for instance, I have example for C. All right. If I have A is equal to -2501 and B is equal to 3, 5. Oops. Try that again. And I want to take A minus B. Is there a way to match up all of those elements in the matrix? No, right? No way, Jose. This is a 2 by 2 and this is a 2 by 1. They don't match up. And the reason why you can't put them together, now this column we could pull off. But what am I supposed to do with this? There's nothing over there. So if they aren't the same dimensions, then you can't add those together. It's called a dimension mismatch. Or cannot subtract in this instance. Dimension mismatch. All right. So adding and subtracting matrices, then you have to be able to put all the dimensions together and put those up. All right. Not too shabby, right? Cool. So we can add, we can subtract. Let's multiply. If I have a number on the outside of my matrix, it's called scalar multiplication. All right. With scalar multiplication, I have something like this. Oopsie daisy. It's example 5. Where I have 5 on the outside. And I've got 2, -3, 0, 4. What do you think you're going to do with this? Exactly. Just like we did with the negative sign, you are going to distribute this to every single term. Scalar multiplication. It's like just distributing it through. So you get 10, -15, 0, and 20. That's it. Literally, that's it. Pretty sweet, right, guys? Yes. I love it whenever we do matrices because they're so easy. Okay, example 5B. Look at this one. Ooh, we're going to get fancy on you and put, oopsie daisy, Put a fraction in front. What? 20, 36, 12, negative 16. Now this one is, they just made it nice for you because look at what just happened. And this is where, so when you get into calculus, you're not going to have calculators, right? So now is the time to figure out how to work some of this stuff if you don't already. This is the same thing as 20 over 1. When I take this 3/4 and I multiply it by 20, this 4 goes into 20 5 times, right? So, and it cancels out this 4. So now I really have 3 times 5, and that's going to give me 15. Do you see what just happened? 3/4 times 20. 4 is 5. The ones on the bottom make just a 1, and then we have 15. So you never write the 1 in the bottom. You just have 15. Same thing that's happening here. 4 goes into 36 9 times. 9 times 3 is 27. Or do you see what is happening here? Okay. 4 goes into 12 3 times, giving me a 9. And 4 goes into negative 16, negative 4 times, giving me a negative 12. So when you have that scalar multiplication, all you're doing is just multiplying through with that number, whatever's out in front, times every single element. And that's the key to that. All right?